Hello everyone, I am Hằng. In this video, I will talk about the rolling without sliding. So firstly, let's talk about I will give you example for rolling without sliding, okay? Suppose that I have an object like this and I make it roll. So if it roll like this, we call roll without sliding. Another example, if I have an object like this, it's like a wheel, and when I make it roll, and sometimes it slide like this, and then it's roll again. In this case, we call roll with sliding. In our course, we just talk about roll without sliding. So we just consider the first example that I showed you, okay? So if we have to write in the formula, so how do we do it? How do we write it? Here is the example. Here is the example. How to write it in formula for rolling without sliding. I have an object, a yellow one here and the blue one here. If the velocity of A equal velocity A with respect to ground equal velocity of B with respect to the ground. So in this case, we have we don't have a sliding of the yellow one on the blue one. Okay. Next, what is rolling? It is a combination of rotation about a moving axis. This axis through the disc move like this, and the other points on this object will rotate about this axis. So we in this case we call rolling. So we have rolling with sliding and rolling without sliding, okay? In this case, we just consider rolling without sliding. So there are three cases. The first one, you consider this case, translation of a point of the object and rotation about the axis through this point. For example, like this, you have the object and you consider any point here. For example, this point here, you consider this point. So translation of this point and rotation with respect of the object with respect to the axis passed through this point. Okay. The second case, you consider firstly, you have a center of mass. It's right here, for example, and the translation of center of mass like this. The second one, rotation of the other particle of the object with respect to this axis, the axis passed through the center of mass. So the third case is like this. You have a system like this. You have a translation of this point, we call it center of instantaneous velocity, and we have a rotation of these planets with respect to the axis passed through this point A. So in this video, we just consider the two cases, the first one and the second one only. So next, I will talk about the velocity in rolling motion. For example, I have a object, a disc like this. And now if I want to calculate the velocity of m with respect to the ground in the rolling motion, so how do I calculate it? Firstly, in rolling motion, so I have a translation of the center of mass. and I have a rotation of the other particles on the object with respect to this axis, the one passes through the center of mass. So if I consider any point on this disk, for example, this point, we call it m. So the velocity of m with respect to the center of mass is like this, and like this. And later, here it will be like this, and here it will be like this, and here it will be like this. So it's always like this, by this direction, with respect to the center of mass. Next, the velocity of the center of mass with respect to here, with respect to the ground, is always it always has this direction. So if I want to calculate the velocity of the m with respect to the ground, so I have to calculate by this way. If I want to calculate the velocity of m with respect to the ground, I have to take the velocity of the m with respect to the center of mass, this one. The one just keep moving like this, by a circle like this, plus the velocity of the center of mass with respect to the ground. Okay, like that. Remember that if any point here on the object, so its linear velocity with respect to the center of mass have the relation with the angular velocity like this. Okay. Next, how to solve problems rolling without sliding. The first method, we consider the case when the rotation with respect to the axis pass through the center of mass, like this, okay, like this, okay. So in this case, you have to pass 3 steps. The first one, you have to write the second law of Newton for the translation of the center of mass here. The second one, you have to write the equation of rotation of the other particles with respect to the axis through the center of mass. So you write this equation of rotation like this. The last step, you have to remember the relation between the tangential acceleration, this acceleration, with the angular acceleration. You have to remember 3 steps like that. So if you have 3 steps, so you have 3 equations, so you have 3 unknowns, so usually you will have 3 questions for that for the 3 unknowns. The next method, in this case, the translation of the point A having VA equals 0, so you focus on only on rotation. So in that case, you apply this formula. Okay. In this video, I just show you the example for the first method only. So the example, suppose that I have a solid disk or solid cylinder. Move down like this. So usually we have, what did I say before? You have 3 steps. You have 3 equations. So you will have 3 unknowns. So the questions are usually related to these 3 unknowns. Okay. Here, the first one is acceleration of center of mass. The second one is angular acceleration. So that one is step 3. And then the friction of force, that one is step 2 when you have equation of rotation. So this friction will make the system rotate. And the final, the condition for having rolling without sliding. How to do it? You have 3 steps. The first step, you write the second law of Newton like this. How many forces on them? So you count it and you put it here. And total, the net force equal MA, and then you project on the OX axis, so you have this formula. You project this one on the OY axis, so you have this equation, this And the next step, step 2, you write the equation of rotation. The torque here, the torque equal I times 2 alpha. And the third step, you remember the relation between the tangential, the linear acceleration with the angular acceleration like this. And then you put this acceleration to, from here you get the alpha, and then a relation between alpha and AR. So you put it here. So you have this equation. And then you combine this equation with equation 3 here. So you have because of friction equal normal force times to the constant, and normal force is, you define it from here. So you put it here to the formula for friction. So you have this equation. From here you can calculate the you get the formula for acceleration. And when you have from this equation you can calculate the friction. So you have formula for acceleration, you have a relation when you have a linear acceleration, so you can define the angular acceleration, you have a friction, and you have a normal force here. So now if now depends on the given. If the given you have a disk or a cylinder, solid cylinder, so I here equal this one. So you substitute I to this position. So you have a like this, you have a alpha like this, like somewhere there. You get A, you divide by R, you have an alpha, and you have a friction like this. Okay. Next, if a solid sphere, so you do the same because the I is changed. So everything following the I will be changed. Okay. Or you have if you have a hub, so I like this. So you have A and friction like this. Now we move to the condition. Okay. The condition. So we consider what? Rolling without sliding. Without sliding, that means the friction here has to this one, the friction is smaller than the static, the maximum static friction. Okay, if it's greater than, so this one doesn't roll anymore, it's slide down. Got it? Okay, that's all. And here the example for the second method. So you do it yourself. Okay, thank you for listening.